This is going to be my world building video. The point behind this is to start you all thinking about how you're going to organize your game world. It's one of the common deliverables. But the thing about it is that it's going to be different depending on what kind of game it is you're going to be making. Whether you're doing a layered parallax background for a platformer, whether you're doing a tile-based system for the world, where you're doing a point-and-click adventure with a lot of different things on the screen to interact with, or a three-quarters view tile world, like the old Roller Coaster Tycoons or any of the kind of mini economy simulation games on your cell phone. It's going to depend a lot on your design. But there is still some commonality with how we're going to structure them. So, to get started, I'm going to show you just the basic concept of what the world needs to look like depending on your game, and then how you're going to build out what that detail looks like for your midterm project. For the final, it might even turn into an editor that lets you work with the map editor if your game requires that kind of level of support. It will be up to your project design to determine that. But for now, let's just get started. So let us make, not an entity, we're going to make a world. So pound if and def world h, pound if and def, oh no, pound define world h, and if. You're going to see this line of code quite a bit. Now let's save it as the header file, world.h, and now let's start getting type defining. Type def struct world, or level, whatever you want to call it. For now I'm just calling it world because I don't know what it's going to be. These are going to, you can hard code them. So for now, what I want to do is just define what I'm going to have as the world. So for this, I need to have a background. So I'm going to make a sprite star background. If I'm going to have a sprite in here, I'm going to need the sprite header file. Pound include sprite.h. And this is going to be the background image for the world. I'm going to have a tile system. Let's make this a top-down tile-based maze type of a situation. Or maybe a side view tile-based world like a Mega Man old school NES style. So let's go with tiles. I'm going to go with uint8. I'm going to call this tile map. This is going to be, oh, and this is going to be also star. The tiles that make up the world. The way I'm going to use this is as one big long buffer. So in order to figure this out, I'm going to need some additional information. I'm going to need my tile width and tile height. So let me declare uint 32 tile height, uint 32 tile width. And this will be how many tiles tall the map is. How many tiles wide the map is. And now we'll actually need the tiles as well. So I'll add another sprite here, and we're going to go with tile map, or tile sheet, or tile set. Sprite containing tiles for the world. And for now, I'm going to leave it there. This will have to grow as we would expand on the topic. Just like with the entity system, it was meant to be bare bones, just to show you what the the framework looks like. This is going to be a bare bones world to show you what the structure is going to look like. If we have a world, well, we need to create a world. So we're going to make world new. And this is going to return a world star. We're going to allocate a new world. And then we're going to, if we create it, we're going to destroy it. Void world free world star world. Oh, let's not forget that we return null and error or a blank world. And the same thing here. That brief, free previously allocated world. And the parameter here is world, the world to free. The idea that we have them as not a singleton is because we might want to preload. You think about games that are like have massive open worlds, they're probably actually broken up into chunks. And what we'll do is we'll load the world that we're loading into first, and then we'll load any nearby worlds ahead of time in the background so that we don't need to show the user load screens after the initial load. Like once we're in a world, if we're going to go to the next world, we don't have to wait for all the disk operations. We can just have that preloaded and then move into it and then free up the one that we just left. The world itself is going to need to be drawn. A lot like an entity, and we need to point to the world that we're going to draw. And not drawn, world to draw. At brief, draw the world. At param, the world to draw. All right, that's the beginning. So let's start working on this. Let's make a new file. Pound include simple JSON .h pound include world.h and my end of line edit file. No, it's not required. Yes, I'll do it forever. Oh no, I put it in the wrong spot. That's fine. We'll move it later. World.c. We'll move it now. Can I move this? Not from within here. Well, what I can do is I can control, cut, save, delete the file. Yes, delete the file. New file, paste, save. Make sure this goes into game framework. Include. And now we have world.h in the right spot. Yay, it's in the right spot. All right. Now into the C file. All right, so world new. We are going to actually allocate. So we'll need a world pointer to work with. World equals GFC allocate array. Size of world. How many worlds do I want? One. In theory, if you're going to have a lot of different worlds open at the same time, then you're going to want to make this look like a resource manager. If I'm really only going to have one world active, or maybe the next world active as well, maybe I can get by with not having multiples. For now, I'm just going to go with this model rather than going through the entire rigmarole of going through and making the other thing. And now a little error checking, if not world, failed to allocate a new world. And return null. And for now, I don't really have anything that's set into this world, so I'm just going to return the world. But in theory, all boilerplate code would go here. No, all defaults. And now the default is 0. free world, we are going to need to, everything that we've allocated, we must free. So first of all, if not world, return. And now let's take a look what's in our data structure. Pretty much everything with a star, we're going to free. We're going to clean up now that we're done. So world background is going to be sprite free. Tile set, same thing. Now the tile map is an integer array. So what we're going to do is going to just free it like so. Oh, you know what we should do? We can make the world new take the width and height of the tiles. So let's go with uint, did I say 32 by 32? Uint 32. All right, uint 32 width, uint 32 height. So now what we can do is we can set world tile set equal to GFC allocate array, size of uint 8. How many of them? Well, height times width. And in fact, we can probably even do ourselves a little sanity checking before we even create the world. We can say if not width or not height. Return null and slog and say cannot make a world with 0 width and height. Cool. Now let's talk about we've allocated it, it's all 0. So now we have a tile map. The tile map is empty, but that's fine. We're good to go. Oh, but once we have these set, let's also now record the fact that the world tile height equals height and world tile width equals width. And once we're all done freeing all that stuff, we're going to then memset world. Actually, we're not even need to worry about that because we're going to free it. We're going to free world. Oh, and look, I need specifically the world's tile map. Tile map, tile set. Tile set was the array. Tile map. And also I'm inconsistent here. So these are camel cased. Make that camel cased as well. So the tile set is that, and tile map is that. Okay, good. Now we're going to world draw. If not world, return. And then first thing we're going to do is we're going to draw the background of this of the background. Doop 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 doo. Where is the world? Actually, where's game? Game here. We're just going to do this. We're going to sprite image draw. But instead of drawing sprite here, we're going to draw world background. And then we are going to have to draw the world tiles. So we'll need some counting variables. Int I, comma j. For I equals 0, while I is less than world tile width, I plus plus. But outside of this one, we're going to do for j equals 0, while j is less than world tile height, j plus plus. here, we're going to draw the tiles. Let's take a look at our sprite stuff again. We need a simple one. We're not going to do too crazy with the tiles, so let's do regular sprite draw. I don't think I have an even simpler one than this. That's not just a flat image. Draw to surface, that's easy. We're going to need this one in a bit. And now what we're going to draw is, we're going to draw the world tile set. The position is going to be based on the vector 2D of whatever you'll see in a second. Actually, the first thing I need to do is if not tile set return can't draw with no tiles. Scale, we're going to keep that nulled out. With a scale from the center, doesn't matter. Scale from the rotation, we're not going to rotate the tiles, we're going to keep them axis aligned. We're not going to flip the tiles. For now, I'm not going to color shift them, but maybe we will later. And the frame, let's talk about frame. Let's make int frame. So let's talk about what we're doing here. In memory, what we're going to have here is a whole bunch of zeros, like so. But what we want it to actually look like is going to be this as our tile map. So we have some number of tiles wide, which is what the tile width is for, and some number of tiles tall, the tile width. But in memory, it's all one big array. So I need to index into this based on my current height. So what I want to do is I will determine my frame, my index into this array. Let's make another variable, int index is going to equal my I position, so where I am on the left, plus my J position times my tile width. So in this case, I have a tile width of, I don't know, 16-ish, 20-ish. So, so if this is 0, this would then be 20, 40, 60, and the I is counting this way. So if I wanted this, I would have a J of 1, an I of 2, and it would end up being 22. So J times 20 gets me here, plus the I gets me there. Now, in order to know what frame I'm going to be doing, now I need to now access that spot. I'm going to let 0 be blank. So I'm going to have a blank tile to draw instead. So if my tile map sub index equals 0, so if tile map index equals 0, I'm going to skip this iteration of the loop. Otherwise, what I'm going to do is draw the frame. Now the frame is now going to equal my index minus 1, because my frame is going to be based on a tile map that I'm going to make real quick with GIMP. And I'm going to make a 64 by 64 tile. So create new. I want it to be filled with, doesn't matter, my width. I'm going to make 2 tiles, so I'm going to make 16 by 64. All right, so I'll have 4 tiles vertically aligned. And what I want to do this, if you haven't worked with GIMP, I'm not really going to go through it right now, but so I'm just going to do this quickly. I'm going to go to Edit, View, show grid, image, configure grid. And I want my grid size to be 16 by 16 and give myself a nice garish color to showcase what we're looking at. And that's not 15, I wanted that to be 16. 16 by 16, cool. And snap to grid, cool. Now let me select just the top tile. I'm gonna go to fill, pattern fill, and let's grab some random pattern we have here, and so that's one image. And then the next tile is going to be this one. You can see how cutting edge this tile is going to be. We'll have a wood grain pattern there, and then finally water pattern here. And I'm going to file, save as, go to Git, GameFramework 2D, images, backgrounds. First of all, I'll save this as a tile set here, but then I'm going to file export as tileset.png right there. Okay, that'll be my tile set. Fortunately, I do believe that is all I have time for right now, so I'm going to cut this video short. We're going to pick this up with a part 2 coming shortly. Thanks for watching.